and Joy. So TJ can have the fractions, and the rest of us will just do whatever. We'll do something easy. Okay. This is something that we really don't teach until later in the year. But I don't know. We have already done so many of the different concepts that are in the rest of the things that we studied this year. Thank you. And there's nothing wrong with giving you new things. So with this, you would have to get common denominators to add and subtract, right? So messing around getting common denominators can sometimes be a little bit of a pain. Yeah. But if we were going to do this, we would subtract 4/5 from both sides. And then you'd have a on the right-hand side is equal to 10/3 subtract 4/5. So if you write all of that out, you need to have a common denominator, which is going to be what? 15. So we have to multiply top and bottom by 5. So this is 50 over 15. Subtract 12 over 15. And then you end up with how much? 38 over 15. And you can leave your answer like that if you want. If you don't like fractions, fractions that are written like this, what they call improper, you could change that to 2 and 8/15, right? Yeah. And you might need to do that if you're going to graph it. So keep that in mind, but you don't have to if we're just working with numbers. But there's another way to do this. And you don't have to do this. So if you're not happy with me showing you now, wait, we'll spend more time with it later. What we could do is this. Take the whole thing and put it in parentheses, big bracket parentheses. And 3 and 5 has a least common multiple of 15. If you count by 3s, 3, 6, 9, 12, 15. And you count by 5s, 5, 10, 15. 15 is the first number you come to in common, so that's the least common multiple. And then what you do is you multiply every value in there times 15. So what you do is you take 15 times 10/3, and you take 15 times a, and you take 15 times 4/5. So it requires that you know a few of the other skills that we've gone through last year. But yeah, I'll show it to you. Now before you multiply, you can simplify 15 over 3, which is 5. And then 5 times 10 is 50. And this is 15 times a. And 15 divided by 5 is 3. So 3 times 4 is 12. Now when you subtract 12, you get 38 is 15 times a. But then you have to remember something that we did last year, which we'll be doing again here soon enough, is that to undo that multiplication, you have to divide. So there it is. Maybe it looks like more work, huh? But it makes it so that when you do this addition and subtraction and such, you're using whole numbers, not fractions. Don't worry about it if you don't like it. That's okay. In time, we'll eventually work with it. Okay, so then you also said 13, 14, and 15. Okay, so 13 at the right is a screenshot of a table in a graphing calculator showing the solution to the equation negative 5.5 plus x is equal to 4.25. So what they did is they went into the y equals and they put in this equation negative 5.5 plus x. And then in that table, there's all of these possible values of y for different values of x. So what is the solution? Well, they said 4.25 is the y value. So what you're doing is you're looking in that table where y is equal to 4.25, and next to it, the x value was 9.25. Is that right? Or is it 9.775? Yeah, good, that doesn't work. So in that table, on the left-hand side underneath the x's, there's a row where it's 9.75, and then over here where the y's are listed is 4.25. So how do I know that that's a solution? Because if it gets added to this number, it equals 4.25. Take 9.75 plus a negative 5.5, that's 4.25. So a solution is just something that you put into an equation and it works. Like this. This is the solution to this equation, or the solution to this equation, because if you put 2 8/15 in here and you add it to 4/5, you get 10/3. It does work. 14. Use a graphing calculator to solve x plus negative 14 is equal to negative 1. Do you have your calculator? So if you go into y equals, so they say that this is equal to negative 1. So what I just circled there, that's what y would be when you go to your graphing calculator. So if you go to y equals and do x plus negative 14, y equals upper right-hand corner. I'm sorry, upper left-hand corner. So hit y equals, and then type in x, which is xt, theta, and n. What? Yeah, that's okay, so you're in y equals, yes? And then you go to x.
I'm lost.
Yeah, then you do plus, and then you do the negative symbol, which is in parentheses on the bottom right. Go to y equals. X is xt theta, that's right next to the green alpha key. And then you do addition. And the negative is on the bottom right next to the equal sign. It's a negative symbol in parentheses.
Negative.
Y equals.
Negative what?
Oh, clear that. And now do x plus negative 14. Okay. No? You have a calculator there in your lap? Y equals. Who's going to be tough? Help each other. You're sitting next to one another. You guys can help each other faster than I or Lori can race around. Y equals? Up here. Okay, now X. Get 2 hands on this thing. It's not a cell phone. X T theta right there. Plus negative 14. Okay, now are we in? Yeah, is it 14 or 15? Change your 15 to a 14. So the negative 1 you're not going to put into your equation. You don't put, so all you're doing is, you're just entering this. So the last question is going to make sense in a minute. Now, let me make sure I got this in here. Are we in now? Are we good? Okay, so go to the upper right-hand corner and you will see table. But before you go to table, above the window, which is in the top row, there's a blue TBL set. Do you see it? Staring at me, you're not going to see it. You got to look at your calculator. Tell me whether you see it or not. So up above the window key on the top row, it's written in blue TBL SET, table settings. So you need to hit the second key and then the table settings. Don't go typing anything unless you know what you're doing. Once you're in table settings, you see where it says table start? Make that a 1. You see where the triangle TBL is? Make that a 1 if it's not. Okay, so what those two things mean is your table that you're going to create is going to start with x being equal to number 1. And the change of the x values, your table is going to jump by 1s.
Then we hit what?
So make your table start 1 and your delta table, which is the triangle table, start at 1.
Yes.
Okay, then you see the graph key in the top row, far right? The second function of that is to look at the table. Now do second and the graph key. Ah. So you should see an x and a y sub 1. So there you are. You got them all? So now you can use your arrows and you can scroll up and down until you find a y value which is equal to -1. And if you scroll until you find the y is equal to -1, there will be, yeah, it's not infinite, but it goes farther than you'll ever go.
Yep.
Then what you can do is you can see what x value goes with this y. You gotta look at the y value. Find -1 here. Yeah, and then that's the x that goes with this y. Okay? So what y value goes with -1, or x value goes with -1? 13. -13 positive.
I got -15.
Well, if you have -13, then you have your equation entered incorrectly.
I'm -15.
Well, then you have something else wrong too. Let's see what your equation looks like. Oh, okay. Then you'll see that x. You good? Rocket scientists, you ready? Pull up the light. Put it back in. X plus -14. How are we doing over here?
When you scroll down, you can see part of the y side line is -1.
This is when x is equal to -1. You want y to be equal to -1. So when y is equal to -1, then x is equal to correct. Y is equal to -1, not x. You okay with it? You sure? Yes? Yeah? Okay, it's time to move on. So you go down until you find y is equal to -1. Scroll down now. Keep going. And y is -1, x is 13. Okay, so what the table is doing for you is this. You remember way back in beginning of the year last year, we would make graphs, and I'd say start with a t-table like this, and pick some values of x, and then figure out when those values are plugged into this equation, what is y, and we drew a line with those points. That's what this is doing for you. You give it the equation, it's making a table that goes forever and ever. And you can change that table, so you can look at tenths, like 0.1, 0.2, 0.3. But those are all x inputs. The solutions are the y values. Those are the solutions. So in question 13, they were just giving a picture of what you just looked at, but it was a different equation in question 13. It was this equation up here. So what this tool allows you to do is if you need to come up with a bunch of points that are on the line of an equation, you type in the equation and then you have as many points as you want. Okay, 15, 29 plus a minus 6 equals negative 4. Can somebody read that one to me again?
29 plus a minus 6 equals negative 4.
Is that correct? Okay. All right, so with this, you can do it in a whole bunch of steps if you want. You could subtract 29 from both sides like this. Now you still have a minus, excuse me, a minus 6, and then this is a negative 33. And then you could add 6, because that's the opposite of subtracting. And then you would have a is equal to negative 27. That's one way to do it. But I think what they want us to do because we have the algebraic definition of subtraction, they want us to use that with these two numbers. So I think what they'd like us to do is change the subtraction of 6 to the addition of negative 6. And then 29 and negative 6 is 23. I'm glad some of you are writing this down. I guess I'd be willing to bet that very few of you have it this way in your notes. But I'm not doing this because I'm showing you ways that are optional. I'm writing all this on the board because this is what the expectation is becoming. We're showing your work. We need to show our work line by line more and more as we go. Because it's not going to get less complicated. It's going to get more complicated. So keeping track of how all these numbers are related is important. This is one option, but I think that the authors of the book are trying to get us to see this idea. Then when we subtract 23, we get the same answer, but the process is a little bit different. They're trying to get us to see how to do something that we're going to use in the future to make work actually more doable. I'm surprised the question of the property didn't come up. The idea of adding numbers. But I'm showing subtracting 23, right? But what if we used this property to write subtracting 23 differently? Instead of subtracting 23, what could you write here?
Plus.
Yeah, plus a negative 23. Now, you don't have to do that, but it's good to remember and know that it's happening. Just adding a negative thing, the sooner you're comfortable with it, with regular numbers, the better off you're going to be in particular next year when you're doing it with variables all the time. Would you like to ask anything else? Okay, next lesson is more of the same, but a little different. And in the beginning, in the introduction to the next lesson, they talk about luggage. And if you fly on a jet, how heavy can your bag be before they start charging you a whole bunch more money? How many pounds, do you know? 50. It's 50. You go over 50 and all of a sudden it costs
I
money.
think it matters on the,
Lots of money.
airlines.
No, this is standard. This is something that's governed by
International?
by FAA, yeah. Federal Aviation Administration has a regulation that your bag can only be 50 pounds, and if it's more than 50 pounds, then it has to be handled differently. One person doesn't pick it up when they're moving it around, 2 people have to get on it, so that costs money. So you go over 50 pounds, that costs money, or they just won't check it. It's real simple. So it's not like a seaplane's limit. This is a different thing. When you're flying on commercial carriers, each bag cannot be over 50 pounds. So what they do is they give us an example here where this person has 16.85 pounds for the weight of their suitcase. So everything's in pounds up here. And then they use M for a variable for how many pounds could be added to the weight of that suitcase. It's a heavy suitcase, but whatever. Now, this has to be less than or equal to, so it can be up to 50 pounds, but not more. Less than or equal to 50. So this is an inequality that's written kind of in that same form of what we were doing yesterday. A, or x plus a is equal to b. So this is like x plus a is, in this case, less than or equal to another number. And that's what the title of the lesson is. So when we solve and figure out what m is equal to, or could be equal to, we use almost the identical steps. But our answer is going to be lots of different things. So what are numbers that would work? What are possible solutions? 10. It's another one. 18 pounds. What's another one? 25 pounds. So if I put 10 in here, I'd be at 26.85. So is this a true statement?
Yes.
Yeah, it is. If you put 18 in here, it'd be 18 plus this number. Is it still less than or equal to 50? Yeah. Okay, so how do we find all of the solutions? Yeah, so here's what I'm going to do. I'm going to rewrite this. So we subtract the 16.85, just like we did with the other equations we worked with. Or you could add a negative if you're happier doing that. It's your choice. This 0 cancels. These two numbers put together make 0. So here's m. Don't forget you're using less than or equal to, Isla. You're not putting equals in here now. It's a common mistake that you get all the way down, you put equals at the end, but we do not. What we start with for a symbol, we end with. So what's 50 subtract 16.85? 32.15. That doesn't seem right. How about if we do it in our head?
And then I did it in my head and I got 32.25.
Well, here you have to borrow, right? So there's the 15. And then this becomes 49, subtract 16, so that's 33. Does that work? Yeah. That kind of thing you shouldn't need a calculator for. So M, in other words, the weight of all of her items that she puts in the bag has to be less than or equal to 33.15 pounds. We do this all the time when we have visitors from the States and we send them home with a cooler of fish. We know how much that cooler weighs. We know how many pounds of fish we can give them to get it to hang right at like 49.5 pounds. And then we send them home. So when we have something where it's equal to, it's real simple, it's a single number. But this here we need a graph. And that's the one twist that we're gonna have with this lesson. Take a question like this, and you have to put its answer onto a graph. So you put these onto a line because it's a single variable. Put the letter of the variable at the end. This is the end point. So you don't want to put, 50 tick marks on there and then find 33.15. With this kind of graph, I think if we had 0, and then the end point, that would be good. And this is going to be one of these things where it's either open or it's shaded closed. And then we shade along the line. So at this end point, is that solid or is it an open circle?
Solid.
Solid, because
And it's
it
equal.
could be equal to. So that's like this. Now, which way do we shade, more or less? And how far do we go?
And yours.
We go to 0, because we're not going to have negative weights, right? So even though this is not written as a double inequality, it still has 2 endpoints because that makes sense. You don't have negative weight. So there's 2 properties. The addition property of equality and the addition property of inequality. So in this case here, we subtracted 16.85, or we could think of it as adding a negative 16.85, but we did it on both sides of the inequality symbol. And that allowed them to stay even. It's like if you're taller than he is and you both grow the same amount, you're still taller than he is, right?
Yes.
Yeah. So with the addition property of equality, if 2 things are equal to each other and they both change by the same amount, they're still equal. So we could think of this as if A equals B, then A plus C is equal to B plus C. In other words, the C we add as the same value to both sides of the equation, and they're still equal. With inequalities, it works that way also. If one number is bigger than another, and you add the same to each number, the result is going to have the same relationship. This is still going to be greater than this. That's what those 2 properties say. And we use those when we solve these problems working with inverse operations. So just like the order of operations are rules, these are rules that are said to be true also. Without knowing that these rules are true, we can't justify the math that we do. Long. That's okay. I am going to do example 2 with you, which is on page 315. This is a guided example problem. And the idea is that you could actually do it yourself if you wanted. So this is it. So it's a word problem, and it says a school club is collecting cans of food for a food drive. they want to collect at least 1,500 cans by the end of the year. In September, they collected 350 cans. In October, they collected 475 cans. So what we're supposed to do is find out how many cans do they have left to collect, and we need to graph it on a number line. So this is an inequality problem. So you've got 2 months that they collected cans. What was September, how many? 350? And what was the next month, how many?
October 1st,
475. So what we're gonna do is we're gonna say on this side of the equation, this is what they have to collect. And then on the other side of the inequality, we have to say what their goal is. So what is their goal?
1,500.
1,500. So everything over here needs to add up to be at least this big. And they've got 1 more month to go. So this 1 more month, we have to give it a variable. What do you want to give it? N? Is that what you said? Okay. Is that for November? September, October, November? So the inequality that's here has to compare this value to this set of numbers that are added. So which has to be bigger, this number or 1,500?
1,500.
Okay, so if I did this, then I'm saying everything that gets added up is gonna be less than 1,500.
No, it has to be bigger and equal to.
Yeah, so it's gonna be greater than. And if they get 15, is that okay? What does it say in the word problem? At least. So the least would be this, so it could be equal.
That's what I meant.
Yeah. So setting it up and making sure the direction of the inequality is correct. That's important. So now it's a matter of just doing the math. What would be a first step?
Doing the addition.
Yeah, you could do the addition. So put together things that are like terms, things that can be added or subtracted. So how much is this put together?
It should be somewhere around.
Not somewhere around, it's exactly.
800. Okay.
How much?
I just looked
Then rewrite the whole thing. Now what's the next step? Subtract 825. Now do the subtraction. How much is that?
at it. Huh.
So we gotta borrow 100, right? Because then we can take 25 from 100, get 75. So now it's 8 from 14 is 6, so there's 675. So the number of cans has to be more than or equal to 675. Kind of read through these when you're done, because if you did have the inequality pointing in the wrong direction, the answer might not make sense. And it will be easier to catch when you check your answer at the end. So now we want to graph that on a number line. Call it N. What points should we mark on the number line? Clover. You could put 1,500 out there. But this, what we're gonna graph is how many they need in the month of November. So what numbers for sure have to be on this number line? 675. And I heard somebody say 0. I always put 0 on. Near always, unless you have a whole bunch of other numbers. But this, it's pretty straightforward. You don't have to have, all of the hundreds and everything on there, unless you feel that it looks better for you that way. But the end point is a must, and 0 or at least a couple numbers that we can read and see which direction the number line is increasing and decreasing by. So if you didn't want to put 0 here, maybe you put 600 and 500 and 400, and that would be enough. But this is a good start. So, at 675, is it opened or closed? Closed because it's or equal to. And then which direction do we shade? Yeah, we shade greater than this. And don't forget to shade the arrow. And that's it. So you're page 316.